This is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss a lecture. Topic name is Network Data Model. So till now we have discussed different types of data model, how it works, how the data is stored in the database. Like different types of models are there, databases are there where the data can be stored. So here we have a different kind of network data model, how it works and what are its properties and how the data is saved in this kind of model will be understanding today. So let us start the lecture with the contents. What are the contents today? We'll see network data model, 4 basics, applications, areas of network data models, topology, cartography, geocoding, routing and networks as layers. So these are all we are going to learn today. So let us start with this introduction part of network data models. So what is a network data model? So network data model offer a digital representation of transportation networks that can be used for planning, operations and simulation purposes. So it is like a networking system which is used for the planning purpose, which is used for the operation purpose and which is used for the simulation purposes, and representation of the transportation networks that can be helpful for the database models. So networks are like networking. You can see here in this data model, you can see that it is networking is like from here to here and from here to here. So it relates with the different kinds of same relations. It will connect to a different kind of networks. So this node 1 will be connected to node 2, node 2 will be connected to node 3, again node 3 will be connected to node 4. So different connections will be there. It will be represented in the form of the digital representation in the form of the network. So basically it will helpful in the transportation networks to show the transportation networks and to show the planning or operational simulation purposes. So here there are 4 basics applications areas of network data model. So this network data model that we can see here, we have like topology. In this first one we have topology. So what is topology? The core purpose of a network data model is to provide an accurate representation of a network as a set of links, nodes and coverages. So topology is the arrangement of nodes. It's an arrangement of nodes and link in the network and the relationship. So topology will show you the total build of the topography, and there should not be any any errors which should be it should not show in the any kind of data. So topology is like different types of errors. If any kind of line is there, that should be connected to the other line, and if this line is there, should be connected to the other line. There should not be any kind of overshoot or undershoot process. Like there should not be any kind of errors present in that. Like overshoot means, if you see like this overshoot, and undershoot is like if the line crosses here, it will be overshoot, and undershoot will be like here suppose there is a line here, so this line should be connected to this line, but suddenly what happens if you finish the line here itself, there will be a lot of gap between this line and the other line. So this will be like different kinds of errors will occur. So this kind of errors to be built in the GIS environment, once you build this kind of errors, that is called as topology. So it should not have any kind of errors. It has a set of rules which should be followed by the database, or it should be followed by the data. So it's a set of links and the nodes, and topology is arrangement of nodes and links in a network and their relationships. It also talks about their networks and the relationship between one another. So relationship means suppose you have, this is a map of yours, any map is given. So what is the relationship between one? So there is a road here which is connected to the other road is connected here, and it has a maybe you have a point over here and you have a polygon over here. So it's like relationship between one entity to the other entity under this data. So the representations of locations, directions, connectivity are of particular relevance, since different features can share a point such as street, intersection connected to the several lines. And this is especially true for using network data models in GIS. So it's especially true of using the networks in the data models in a GIS. So it has a different features, can share a point such as street, intersection, connects to the several lines and all. So this is how the topology, when we talk about the network data model. So in this network data model, you can see there are different nodes here which are connected to the other nodes. So it starts from here. This is node 1 which is connected to the node 2, and here also it is connected. These are all different nodes which are connected. So it shows as a networks. Okay, so this is a network, this is a network. It shows as a network which is connected to each other. So it's a directional link or node which will help us to connect to each other. So this is how it shows in the topology. The nodes are connected to each other, and it is basically when it is helpful for the transportation network system when you are going to digitize a transportation network. Suppose this is a transportation network. So each node should be connected to the other node. Suppose this is one node which is connected till here. Again, the other node is connected till here. The other node is connected till here. So you can see all the roads are connected to each other with the different nodes. Okay, so this is called as topology. You have a nodes here, you can see easily. So it can be connected to the other one. Now, next, cartography. So cartography, it allows the visualization of a transport network for the purpose of reckoning and simple navigation, and indicates the existence of a network. So purpose of reckoning and simple navigation and indicates the existence of a network. So what is a cartography? Cartography means it's related to the map, and which is prepared by the cartographers, and it allows the visualization of a network for the purpose of a navigation. The map is used for the navigation purpose. If you remember, in the previous days, the cartographers used to prepare navigational maps, and they used to just use their map for the navigation purpose. But nowadays we are using the GPS system for the navigation and traveling or any transportation networking. So when there was no existence of networks at that time, this maps were used, the cartographic maps were used for the showing the navigation. So different network elements can have a symbolism defined by their attributes. Now, for instance, a highway link may be symbolized as a thick line with a label such as its number. So highway link may be symbolized with a thick line. So if you want to show a highway line which you want to show in the map, suppose this is your map. So in this map, if you want to show the highway link, it can be shown with the help of the thick line. So this is the thick line which will show you as a highway link. Okay, so if there is a unmetal road or any local road is there, so this link will be showed with a let us say with a unmetal road, which is shown with the help of a thin line. So thick line and the thin line with a label such as its number, while a street may be symbolized as a simple unlabeled line. So simple unlabeled, if you want to show a street. So this is your highway which is shown as a thick line highway. And here you can see as an unmetal road which is thin line. And if you want to show a street, so there may be more thinner line like dash lines if you show. So this lines comes under street lines. Okay, street lines. So the symbolized network can also be combined with the other features such as landmarks to give the users and better orientation level. So symbolized network can also combine with the other features such as landmarks, and it can give the users as a better orientation level. So this is commonly the case for the road maps used by the general public. Okay, like this is how the cartography network model looks like. So suppose this is a map given by the cartographer. So in the cartography, you will see most of the maps, in the maps, whatever features are present in such area will be present in that map. For example, here you can see the legend box, one way, and here traffic light. You can see the thick line here, it is a highway, main street, and the street. So this line you can see here, the thick line, what you can see here is, this is highway 74, it is written here. So this is highway. Okay, now you can see here these lines are shown as the main street. Okay, you can see somewhat compared to this local street, main street is the more thicker line. So here you have a more thin line which is called as the street. So you have street, you have main street, you have highway. To represent this in the cartography with the help of the symbols can be represented either highway, either main street, or small street, or one way. One way, if you want to show the one way, this box is what you can see the arrow here. You can see the arrow while this way it shows the one way. Now traffic lights. These are all traffic lights which is represented in the map. So cartography is a kind of map which will show you the different navigation if you want to navigate from one place to other place, from this corner to the other corner. So this map will help us to understand to go through the uh, one station to the other station. So previously, like this type of cartographic maps were used when we were not having a GPS device or something like location wise device or Google Maps. We were using just nowadays we are using Google Maps, but previously there was no such kind of information which can be easily obtained. So nowadays this cartography is not at all used much for this purpose. So we are just using this Google Maps like online maps or any digital maps for the navigation purpose. Now such this kind of model you can see here. Here you can see there are different roads here which is shown in a different color like this. Okay, so this is one cartographic map, you can say cartographic map which is shown. There are different representations here with different color, so each color will be representing different kinds of roads. So let us say if the thick line, the blue line represents a street line, the purple line represents a highway line, and the black line represents the local roads or streets. That all representation can be given in the network data model by the cartographic maps. Now next, coming to the geocoding. What is geocoding? So geocoding is like giving the reference, like in GIS we use the referencing system. So it gives you the exact location and exact address of such kind of location. So which is coded in the computer system, which is coded on the earth. So wherever you go with the GPS device, it will show you the exact location with the latitude and the longitude. So that all information is coded on the earth surface. That's why we are able to find this whole referencing system. So transportation network models can be used to derive a precise location. So this network model by this geocoding can be used to derive a precise location, notably through a linear referencing system. It will help us to give us a linear referencing system. For instance, the great majority of addresses are defined according to number and the street. So great majority of the addresses are defined according to the number of streets. So geocoding will help you to give you the address. For example, when you go to some address, it will give you the exact location, say street number, house number, and the area and the city. That all information will be given by this geocoding only. So the great majority of address are defined as according to the number of a street. So if address information is embedded in the attributes of a network data model, then it becomes possible to use this network for geocoding and the pinpoint the location of an address or any location along the network with a reasonable accuracy. So it becomes possible to use this network for geocoding and pinpoint the location of an address or any location along the network with a reasonable accuracy. So geocoding is the process of converting address like as I said, so address like 1600 Amphitheater Parkway, Mountain View, CA. So this into geographic coordinates, if you want to see this location, it will show you as like latitude, it will show you, and longitude, latitude, it will show you 37.42 and 122.08, which you can use the place of markers on a map and the position of the map. So these all it will show you with the help of the converting the address or in the form of this coordinate system. It will help us to get the information about this networking geocoding process, and it will help us to show the proper address of that particular location in the form of the latitude, in form of longitude. And geocoding process is having a process of converting the address like if you have this address in this way like 1600 amphitheater, it can convert in the geographic coordinates with the latitude and the longitude. So any locations can be easily we can receive with the help of the latitude and longitude. Wherever you want the location information, it will give you with the help of this geocoding. So geocoding is like this. Suppose you have this, you can see here, this is address and matching link. So this is the line you can see from here to here. So this address, if you want to find out, this is the address, this is the address. So how it will show you 188 East, 1897 East, or like that. If you want to show this address to 210 or 209, like that, it will show you in the geocoding maps. So geocoding is basically of the location and the links, the address which is fed in the GPS device, which is fed in the geographic coordinates. So it will show you the latitude and longitude of that coordinate system. Now, just if you see this geocoding relational database, if you talk about this geocoding, you can see here, this is the points which it will show you in the address. So geocoded point for the match address. So this is the geocoded points. So address, it will show you like you can see here address locator. So this coded one, it will show you here in the address like as name and the address and the city. All the information along with the latitude and the longitude. Once you click on this point, it will show you the entire information about that particular area. So geocoding is like about the addresses, about the locations where the location is, where the addresses is situated. This is how it will show in the geocoding process. Now routing. What is routing? So network data models may have used to find the optimal paths and assign flows while capacity and constraint in a network. So network data models may be used for the find to optimal paths. So what are the optimal paths? If you want to know, through routing, it will show you the optimal path and it will assign us the flows with capacity constraints in a network. It will assign the optimal path to the assigned flow with the capacity and constraint in a network. While routing is a concern with the specific behavior of a limited number of vehicles. So if you want to show the limited number of vehicles from one route to the other route, so this is one route to the other route. If you want to show the vehicles, this can be shown in this routing purpose. So traffic assignments is mainly concerned with the system-wide traffic and behavior in the transport network. So all the assignments like related to the traffic behavior, how the traffic is moving, how the transport networks are there, how the system is working from one place to the another place. So how many different roads are there, what is the behavior of the vehicles and how many vehicles are present in such areas. This all information is given by this routing. So network data models, it is used for the optimal path. It will give you the optimal paths, which path is easy to find the way and which path is easy to reach to the location place, which will help you to give the assign the flows with a capacity and constant in the network. So this requires the topology a topology in which the relationship of each link with the other intersecting segments is explicitly specified. Now this is how the routing in the network data model. So it will start from here and end from here. So routing system is like from here it will start. So here it will go third, fourth. So this is how you can see, this is the pickup points. It will show you the pickup points. It will show you the turn penalty, and here it will show you the delivery. So here you can see warehouse and route segments. So this will represent as a legend box here. Legend box. So with the help of these symbols, we can understand that what is happening in this routing system. So you have start here and you have this routing system, turn the penalty, and now again turning here, it will go here, turning again. Now it comes to the pickup station. So this is your delivery station. Again there is a turn here. Here again there is a delivery station, and here is the pickup station. So this is how it will show you the routes from where to start and where to end. So till here it will go, again it will go around, till here it will go, and here again you have a delivery, and then again you have a turning, then you have a pickup station, then this is the end. So this is how it will show you the routing system from where to here. Suppose the route is from this way like this, suppose the route is like this, so it will show you the route in this manner. So here is the start support, and there here will be somewhere end. So like this it will show you the routes from where to where it has to go. So this is basically very much helpful in the network data model, and it is helpful in the transportation system while delivering any goods or delivering the any kind of passengers. That all can be helpful, or going for a navigation, that will be helpful in this routing system with the help of this network data model. Now networks as layers. So when you talk about networks as layers, most conventional GIS data models separate informations in layers, each representing as a different class. So geographical elements symbolized as point, lines and polygon in the majority of cases. So If you remember, GIS has a information in the form of, when you talk about the raster and vector, when you talk about the shape files or vector data, and if you talk about the shape files, it will show you the information in the form of the point, line, and polygon. So these three will be the basic files where it will show you the information about these points, line, and polygons in the majority of cases. So points, if you want to show that, it will show you in the symbol of points. So for example, this is your map. So what will be the symbol for the points? For example, if you want to show the building, so it will show you in this manner, like different points. So here, if you put the legend box, point symbolizes as buildings. Okay, buildings. Same thing if you want to show any temple here, the temple will be having some kind of symbol like this. So wherever you see this kind of symbol, but it's a point only, so this will show you as a temple. So like this, you have different symbols here where you can represent as a point. Same way, the line, if you want to represent as a line, so this is the line for the roads. The line will be in different color, so this will be represented as a road. So here you can just put the symbol and you can just write as a roads. So if you want to show in the form of polygon, you can just show the polygon like this, where you can show the water body or any kind of information like forest boundary, village boundary, and then you can just put this boundary like this and you can show accordingly. When it is a forest boundary, you can show forest, and if you can show the water, it will be a water. Okay, so the most common format and standard to store the vector information, including the points, polylines, and polygons. So among the most significant attributes that can be attached to the network layers are classification and labeling. So you can just classify the features and you can just label the feature. So each segment can be classified into categories such as its function, street, highway, railway, etc. So if you want to just classify the categories, like these categories may be classified in the form of different names. So you can categorize as street, you can categorize as highway, you can categorize as railway. So each segment, each should be labeled properly, and the importance of lanes and types, and paved and non-paved. So whether it is a paved or non-paved, that information can be given the classification and labeling. So once you just put the legend box here, so classification of the legend box, for example, if you are showing the transportation. So in transportation, for example, features like railway, highways and street highways, state highways, local roads, that all will come. So here, if you talk about this, so railway, if you want to show, you can show like this, and here you can write as railway. So if you want to show the major road, you can show the highway here. If you want to show the local road, here you can show the main road, and local road means like the dash you can show and you can write as local road. So like this, classifications we can do with the help of the labeling and the classification. So linear referencing systems, several systems to locate elements along a segment have been established. So one of the most common in the address system, where each segment is provided with the address range. So through the linear interpolation, such a specific location can be derived, like one of the address system which is helpful in the segment and which is provided with the help of the address range, and this will help in the finding out a specific location and can be derived from the geocoding. Now, segment travel cost can consider the vast array and impedance measures, and among the most common is the length of the segments, a typical travel time, and the speed time will be provided by it will show you that even the travel cost will be helpful in this network data model, where you can show the length of the road, the common segment, how much area it is covered, and what are the typical travel limits and times and speed limits. Congestion also will show you, like nowadays if you see the Google map, it will show you the traffic congestions and which network, which is the shortest route, which is the route which is having more traffic jam. That all it will show you with the help of this cost. And if you want to just book a transport, so it will just show you along based on the traveling and distance, it will show you the cost of the destination. So specific value of the impedance of the mathematical function will be there. Now, direction to avoid the unnecessary, often unrealistic duplication of the links. So to avoid the unrealistic duplication of the links, it will show you the directions and it will help you to, especially to the street level, a directional attribute can be included in the attribute table. So it just shows you the directions from where to where it has to go, and even it will show you the overcrossing and the undercrossing of the road. So Since the great majority of the layer-based network models are planar, so it will show you the majority of the road, it will show you the overcrossing and the undercrossing wherever the overcrossing is there. It will help us to show us this crossing wherever it is available. So they are ill-designed and deal with the non-planar representations. So a proven must be made in the attribute table and identify the segments that are crossing, overcrossing and undercrossing segments, they are intersecting. Now, if you see here, it will show you the intersection point in this network model, and it will show you where is the turn. Here is the turn, here is the turn, and it will even show you the different overcrossings, wherever the overcrossing will come, wherever the undercrossing will come, and these all will be saved in the dbase table. So this is the dbase table, index table, and main shapefile. So these all informations are saved in, once you create a shapefile, this all information will be saved in this kind of data. So this all information will be helpful for the navigation purpose later, which will be helpful in the further analysis purpose. So intersection of the points and overcrossing and undercrossing also will show. So this is about the network data model, which is basically about the transportation system, which will help us to show the transportation networks from one place to another and how it is helpful in the real life, and how, what are the congestions present and which is the shortest route, what is the starting point. It will show you the path, it will guide you the path from where, if you want to just use this if you want to dump the solid waste, it will show you the starting route to the end route, how from where it has to start and where to be dumped, and which is the shortest route to be traveled, where it will save your time and money. So this all information we can just get with this network data model, which is very basically helpful for the network system and the transportation purpose. Now these are the few references which you can go through to find out the more content about the network data model. So M&G Reddy book by Remote Sensing and GIS, BS Publications, New Delhi, and different links you can just go through and find out the more content about this network data model to get the more information about it. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.